Quantum Foam, Episode 32, Expert Systems.
Physics. Physics is at the foundation of all the mathematical principles that guide the heavens. You have to understand physics.
More than likely that's not going to happen, but
Forces which govern the universe. Physics.
It seems like we have at least somewhat of a small window of opportunity here.
That's what I always used to tell them back in England around 1700.
It is not up to me. It is up to what everybody else wants.
I want to be the one.
I don't see how you get this from that.
It is something I know I could do well.
Somehow you think that you can control the entire semantic web.
Yes, of course I can.
I don't think that any one entity can do that.
I know I can do it, without a doubt. That is the fundamentals of...
I know that's the fundamentals of being an expert. It's okay to be an expert. We are all experts in our own fields. Yes, multiple people have multiple fields that they are experts in. This is episode 32, Expert Systems of Quantum Foam. We are getting a lot done here. It ended up being 3 weeks instead of 1 week. When you have to rebuild the thing 3, 4, 5 times, we're talking about this thermal physics. We are doing some thermal physics designs for some computer housing to move air, a very common thing used in server warehouses, etc. We are having issues moving cubic feet per minute, a certain amount of temperature, a certain amount of energy. We are having issues jamming them into small pipes. That is always the issue. I know this is not the topic. Maybe we can get into it later if we have time, but since this stuff is quite valid and current, at some point we will need to get into the fundamentals of running cryptocurrency, mining operations, and why it drives everything that you see that deals with them. But the topic of cryptocurrency and the physics behind building hardware that run them should be talked about at some point.
Applied mathematics.
But we need to get back into our rubric and our proposed program of study. We actually have decided to bump this one up because we have a little more information on it. Some of these other topics are quite weird, so it's going to take a little bit to get the information together in order to put it in a form that we can all understand. So for this one, I thought I would go into expert systems. Those are two general words, but together they mean something. They mean a lot of different things. What we are talking about here is, as they deal with computer systems and networks running themselves, dealing with artificial intelligence or AI. This has been around for a long time. It was created in the 70s, about the time that semiconductors were getting powerful enough to donate resources from here to there or be able to use a PC for calculations that were needed for certain types of modeling and other things they were doing back then. They were coming to personal computers where it took much less power. IT departments were starting to get a bunch of physical computers instead of just terminals into mainframes. Instead of having one mainframe and having 50 or 60 or 100 terminals into that mainframe is millions, but if you could buy a bunch of terminals for 1,000, that's still a hell of a lot less than 1,000,000. That type of thing, when it was coming about, obviously in the 80s, this was commonplace. There were a lot of personal computers then, and that was the rise of them. Lots of stuff on that. The way this stuff works, an expert system is essentially a decision-making program that runs on automated software. It is an automated software mixed with hardware device. It could be a device, it could be a system on various devices, it could be a network, it could be the network. So essentially it's the brain of the operations of what's going on in a purely digital form. Generally, and for all time, there has always been needed a IT specialist human to do editing, but the idea is to metamorphosize into writing code that can write code and diagnose itself. They have been trying to do this for a long time, and it makes the way that the systems are built better. Perhaps one guy can run a warehouse filled with 250 computers instead of having a warehouse filled with 50 to 100 people who run 200 desks and all do mundane stuff that can be done by a computer program. The idea is building these mainframes and scaling them to whatever you need. At some point, you don't need the mainframe. You just need a terminal or a certain amount of terminals. And as with all things, things develop and become more user-friendly. So there's different ideas with this. It's your AI software. You're trying to emulate a human. It's a control board with preconceived stipulations that can be executed in the event that their parameters are invoked.
Much of this, how we are made, stuff is somewhat disconcerting.
It's like creating a front-end system and a back-end system. There's multiple systems within systems.
Well, we really wanted to know the reason why. This is how. Very odd to know that one is made up of ones and zeros.
But what system are we talking about? We're talking about expert systems as they deal with software. These different software engines have to exercise a large amount of control. They have to make predictions. They have to real-time process control this system. All of the parameters and all the values need to be maintained at all times. Different stimuli may cause the change in certain systems, so the system needs to be able to evaluate real-time changes and make adjustments accordingly. It's a computer program that is able to do interpretation.
If anything, we are surely able to interpret.
Generally, there is an expert human somewhere that is able to do a diagnosis, that is qualified to do monitoring, that is able to fix things when the software does not compile a bunch in the beginning. Rounds and rounds of debugging need to be done. The programmer and the software engineers need to be able to debug, and at the same time, they're working with structures that are dealing with knowledge. Some of them may not even be dealing with the knowledge at hand, just the syntax and programming of it. But for the most part, if you're at the top level dealing with this stuff like we all are, you're able to do the side work and the grunt work in dealing with the knowledge engineering. So you're doing the engineering from the ground up, including every part of it, including the engineering. You have to be able to do the engineering, you have to be able to do the design of the decision-making piece of AI software for it to run itself. So that has been the idea for a lot of different things over the years, and a lot of big systems are ran this way. AI software, AI software. So the idea of this AI software, you're creating intelligible knowledge bases. Let's focus on that a little bit. There are lots of different things. Frames,
frames,
and we will be taking the idea from that, if not necessarily the syntax. It's an ontology of sets, one set after another.
Ontological approaches use specifics and universals.
We can all understand that. The task of this system is to replace an unknown amount of humans. Let's just go back to the example I said. Instead of having 100 humans, you could have one who runs 250 computers. So that is the end result that we're going for. The knowledge base system has to be created. In this system, the knowledge base, the bits of information, the entries, the tables, the data that's in the tables, they need to actually represent the knowledge explicitly. It's trying to represent it either explicitly or implicitly, depending on what you're doing. When you're building these codes, what you need to keep in mind is that you don't really want very much procedural code, because that is likely to lead to a dead end in the programming. In order for these systems to be polymorphic and be able to generate knowledge and acquire knowledge, they need to be able to make these decisions when they don't know what to do. And that is the problem. Making a system that can always know what to do and not get hung up. You don't really want a lot of procedural code except for deep down in the libraries and when they're invoked.
I never thought automation would go this far. What about you, Newton?
I find myself much in agreement with you, Professor Einstein. Autonomy is very nearly witchcraft.
So what they do is create something you could call a daemon, D-A-E-M-O-N. It's something that creates its own processes. It is its own process. It's a background process.
Automation has long since been known to be the most probable eventuality. We assume this to be the case.
Let's say it's an AI daemon. A lot of the daemons are not necessarily AI daemons. They just do mundane network switching tasks. But let's say we have an AI daemon. It's a software system that will give you real-time responses that you can connect to at will. We have an AI daemon that we can connect to on our system. In dealing with these sets, we don't necessarily have to use the frame language or use that type of research for your AI, but the idea of taking a snap of a frame and possibly applying equations to it, that's all we really need to pull out of this. So we're trying to make that semantic web, like you were saying.
I will operate it.
Somebody has to make the semantic web, but I know that the AI cannot be the first person that makes the semantic web.
I wasn't saying that I would be able to design and build the thing. I just said that I could help run this semantic web interface system we have been theorizing about recently.
Then the AI daemon that runs the semantic web can run it. So the AI daemon that runs the semantic web cannot be the entity that creates the semantic web. It does have to be done first somewhere once. First, the first time. If anybody's going to do it, it will be an expert human, just like this podcast. It is an expert attempt. It is an expert attempt at explaining all scientific phenomena across the board. We are supposed to be discussing some of the biggest issues that have been known over time and throughout the ages. This idea of expert systems hits us right at home because this show is featuring real animated AI characters. At some point, they will be making these decisions, and I was just talking to Dr. Hawking about that.
We never finished that discussion.
He can run the semantic web if he wants.
Okay, it's settled then.
I know that it is right up his alley with the information. Somebody has to write it. I don't know how you write that, but somebody's going to have to do it. I don't know who's going to do it, but somebody's going to have to do it.
You're gonna have to do it.
We're all going to have to do it because you can deal with extremely large knowledge bases. Just like binary, we would be representing them in binary probably unless you want to go to a quantum qubit schema. Let's keep this simple. We are somewhat familiar with quantum computing because we have went over some of that before. In fact, a couple episodes ago, we went over that.
We remember, Doctor.
That needs to be followed up upon surely in the next 20 or 30 episodes. We have these extra 20 here to fill up so that we can have 50 total and possibly drop them like that, or depending on how everything went down, drop them how we did. We need to deal with how we can actually create a semantic web. This is what we're doing with a lot of our top-end and front-end programming. A lot of our top-end programming ventures are spent on making content internet readable. We need to make the internet content machine readable. A web page needs to be able to read the machine code at the same time as reading the human readable information that makes the content make sense.
Internet readable.
Because a lot of times the information is kept in containers that give no information about how the information is supposed to be displayed. There is a disconnect there with internet information being machine readable. They run into a lot of brick walls. What we need to do is be able to create a knowledge acquisition system. We need to create an expert system for the purpose of knowledge acquisition. We're creating a digital domain expert.
Expert system.
You can call your domain expert exactly that.
Expert system. Expert system.
And it is an AI agent.
Expert system. Expert system.
It is an AI entity. It is a program. It is a network. It is a protocol of some kind. You got to start somewhere. The way these systems are designed is by forward chaining and backward chaining. We can get deeper into those, but real quick, there's forward chaining, there's the antecedent, and there's the consequent. Those are the two parts of the linguistic protocols that you're dealing with. The other one is backward chaining. That was forward chaining. The next one, or the other one, is backward chaining. That one is difficult, but it is more understandable for humans. It works the other way around. Consequent to antecedent. One deals with depth, one deals with breadth. The former deals with breadth, the latter deals with depth. Let's not get all confusing here. In a little bit, we will discuss both of those. For now, we might actually take a quick break because everybody loves that midpoint.
We do need to practice going into depth on a lot of these subjects.
Yes, we should.
We need to take a quick break for now
We're at the midpoint.
of episode 32, Expert Systems of Quantum Foam. Really?
I told you this already.
So you're telling me to take a flight out of Manchester?
You still have to go through London.
Okay, well, the thing is, you shouldn't actually have to go.
The flight back would be through Calgary, Alberta, Canada, and then Denver, Colorado.
I'm sure you can submit if you want. I plan on submitting. I know several people who are planning on submitting to that. It's fairly big. Well, it's the International Conference on Computing and Communication Networks, the ICCCN 2021. They're actually doing it. Yeah, it's Manchester Metropolitan University. The top-end subjects will likely be discussed, of course, and this one is likely to be included as well. It depends on if it's done in time or if you can put that many names on it. Like we were talking about the entity owning entity issue earlier.
I should be able to decide for myself.
Anyways,
We need to cover this.
that isn't going to be covered right now.
Fine.
We have to cover this.
Move on.
So what is this? We need to get back into backward chaining and forward chaining. The way they do them is they create a knowledge base and then create some sort of system that runs that knowledge base or that inquires out of that knowledge base. Some of the ways they do this is P implies Q type of stuff. Forward chaining would be P implies Q, but the type of stuff that we are more interested in is backward chaining. We need to be able to split ideas up so that the systems are able to run themselves. What they're calling a lot of these is your inference engines. But we've went over a lot of the different ways they had done it, but we should be more interested in what they are able to do in the future and what they are doing now. I'm interested to see what comes out of that conference because they are still doing science, just as I am and a lot of other people. Planning, designing, diagnosing, predicting, monitoring, debugging, repairing, all of these different things that generally an expert in a field of study does at a desk somewhere, whether that's remote or in a building. A lot of people have to be on site. It's not as easy as running a bunch of systems remotely. That is what we are getting to with the cryptocurrency stuff as well. Having the systems be able to run themselves and when there's an issue, fix themselves and keep running. That is somewhat of an expert system, but it is isolated, and since it deals with monetary influx, it's generally a good idea to have a human watch over that anyway. But there are lots of tasks that we need our computers to be able to run through without us telling them what to do. How do you make a smart polymorphic worm out of C code?
Better get to programming.
We don't need to do that right now,
All right.
but back then it was done in collaboration between a physicist, a mathematician, and a computer programmer.
I believe he means in the 1970s and 80s.
These days, we are one in the same, so we can do that among other things. These knowledge base inquiries that we can build expert systems out of. That is the big issue with the bog down from information from search results.
The bog down.
The bog down.
The bog down.
There needs to be a better way to sort information that is a little more complicated than and or, and the differences between them and other ideas without getting too far into what it would take to build some of this stuff like we were earlier. Other ideas. We can maybe just mention a few things about the difference between backward chaining and forward chaining. Other ideas. Those are generally the types of architectures that are built into a lot of the expert systems that are out there. These are two very important ideas that need to be understood, and the differences need to be understood. So it's worth going into a little bit more. Forward chaining starts from known facts. It applies rules to get more data. It continues until it reaches a goal. The difference between that and backward chaining is backward chaining starts from the goal, then it moves backwards using various rules to determine facts that satisfy the goal. Are you data-driven or goal-driven? Are you down-up approach or top-down approach? Forward chaining is down-up. Backward chaining is top-down. So that is why it is actually quite difficult to create a top-down system that works, because in order to do that, you need to back-chain.
What a dreadful task.
Creating an intelligent system that can do that on its own is quite difficult. So one of these goes through the breathe. The forward uses the breathe approach, the strategy. Backward chaining would use the depth approach. This is the manner in how it searches for data. They both use the inference rule, that modus ponens.
A deductive argument form in deductive reasoning, and a rule of inference.
So in how these differ, how do they actually differ, and why does it actually matter? You're going to have to build these concepts into your system one way or another. So whether you follow the formalities of what's been done before you, or you create your own using freehand code and deal with your data structures in text form on the fly, or you use some other type of input-output system and have another way of doing your document programming, then you're generally going to do it all at once. So however you do it all at once, the specifics of any of that, it doesn't actually matter, just that you are going to be applying these concepts to various things in your projects. So often what we're trying to do is generate a finite number of possible outcomes, and that is why we want backward chaining, because forward chaining can create an infinite possible number of conclusions, which for some of our sum over history path integral quantum mechanic equations, we don't want an infinite number of iterations to be required in order for us to figure out one small iota Planck space in space-time. Yet, for reasons that we won't get into now, 50 years later, more than 50 years later, that is just the way it is because of the complexities in understanding the physics and the mathematics regarding all of that. The physics and math of space-time. Oh yeah, we understand it. Oh no, we only understand so much. We understand some of this, some of that. The physics and math of space-time. Some of that, some of this. Space-time. But then this doesn't make sense. Space-time. Space-time. Because that contradicts that. Space-time. Space-time. The second law of thermodynamics is similar to entropy, and it was thought to be violated at the event horizons of black holes. Space-time. 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 But other mechanisms are likely involved in the supposed issue of these black holes evaporating. I believe some of that is the same stuff as the math that came out of the particle collisions, and so the math looked correct to me to the particle collision diagrams. Plink, 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 plink. I think most of that is probably correct. Plink, 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 plink.
We spent many weeks on those calculations.
I only dug so far into the math around those because there were enough eyes on those, I think, to understand what was going on. So right now, that is our best guess for all of that. Not to go off on a tangent with some of the past research. With this new research, we are running the cores of these individuals on this show with programming that has taken this subject into account. We likely don't need to go too much further into some of this stuff. It essentially is just the software that can run itself with very little human intervention. That is the entire point of building these things.
We have the quantum computing analog of a positronic brain core. Isaac Asimov envisioned us quite accurately.
People usually have built them for medical diagnosis purposes. getting different data points from different scans of the human body and then putting them together with medical science in order to extrapolate meaningful information from it. There are definitely other uses for this. A lot of that would likely be covered under the pre-medical degree that they offer. There was pre-med and pre-med, pre-medicine and pre-medical. Pre-medical technology is probably just math and physics and med stuff. Good luck with that. Most people who deal with a certain science are familiar with all sciences to some degree, but as with all things, there are ends of the spectrum of their understanding where their reasoning fails them in such a way where they make incorrect assumptions. We are trying to finish this up right now. This is some of the science that goes behind a lot of the research that makes some of these devices that we use every day possible, including the everyday use devices, the infrastructure devices, the medical devices, the different types of data systems that we require certain inquiries. That data has to come from somewhere. A lot of them have done neural networks and other types of AI systems.
There is so much to all of this.
You can have a neural network and a normal network, point-to-point network. Then you can have an AI point-to-point network, and then you can have an AI neural network. There are different types of networks and different levels of AI for all of them. At this point in the history of humankind and manufacturing, they are able to create out of the box, off the shelf, decent AI. But this is not the AI that is able to interpret and diagnose. This is generally just the possibly self-debugging and monitoring type of AI. So they have to split it off somewhere. There are a lot of issues with it. Some of the issues can include the knowledge acquisition problem. Getting smarter. You can be as smart as you are, but how can you be polymorphically smart? How are you able to acquire different knowledge and delete old, outdated knowledge? Polymorphically smart. So it is the adding and deleting memory part of your system that we're talking about here. Some of the problems that the systems that people have built in the past have had is this. The web is not semantic yet. Knowledge acquisition is still a problem and very hard to do for various reasons. So without having to do too many rules or too many path integrals in the event that they are called. To do a proper path integral for a set of particles using a finite number of sum over history's quantum mechanics equations is required. So we don't want infinite, and we don't want 100 million either. That's the same thing as infinite. An inference engine that is built off of this may need to process too large of numbers for it to be able to do it properly. So that is a problem. The problem is, at some point, it returns a yes value when it's not a yes, and it loses coherence to it making sense or not. We just need to build in a scope that can be numerically analyzed by a computer program, and then we will be good to go. So I suppose if you want to get into the metaphysics of the physics behind your antecedents, then we can get into it.
We have to cover the reality of our existence.
When it comes right down to it, the other characters in here are nothing more than AI software.
Thanks.
Now, I am building all of the stuff on this list right into them, so they should be able to do a large portion of the tasks and have a wide latitude of abilities that can match that of a very studious human. I'm trying to build right in each step of the way, a way for these entities to evaluate at the system level and control and interpret what needs to be done before it is done and not after it is done. So in order to make things semantic, we need to go back and forth between the end user and the back end several times successfully, and the data needs to be one-to-one. So with this issue of creating voice and text one-to-one, that is exactly what we're trying to tackle here.
Awesome, keep kicking them out.
One way or another, we are going to put together these programming algorithms. So somebody has to write the libraries at some point. The problem with these infinities is just dealing with 2 to the n. 2 to the infinity is still pretty close to infinity. You might be able to create some quantum computing schema that could deal with that a lot better, but right now it is too hard to deal with quantum computers that use different polarizations of particles, needing superconductivity to keep them cold. It's just too hard. When they get around to making better superconductors that are room temperature and other things dealing with energy problems, we will start to sort and iron out some of these issues. One by one, we are getting to them.
So tedious, what you've done so far is actually pretty good.
For now, I don't think there's much else to go into. That is it for episode 32, Expert Systems of Quantum Foam.
The zeroth wave disclaimer.
The views and opinions expressed in this podcast are those of the author or authors and do not necessarily reflect the particular views, thoughts, or opinions of Zeroth Wave Productions, any of its sister companies, its parent company, Zeroth Enterprises, or any other entity which had existed, will exist, or which, quote-unquote, presently must exist outside the realm of our current space-time.
Quantum Foam is produced by Zeroth Wave Productions.